So here's what we got for the end. Waves and sound. I don't know. No, we just start. No. Okay, here we go. Ready? We've got waves and sound. We've got light and then thermo. Those are three last units. Okay. Might do fluids. We'll see what happens. So, in my opinion, you've made it past the hardest part. Electromagnetism. That was, at least when I was in your shoes, that was the part that was just like brutal. Um, so, today we're going to talk about identifying parts of the wave, calculate the speed of the waves, and identifying types of waves. Okay, so talking about waves, let's do one. Come on, get up. Woo! Yeah, yeah, yeah. Come on. Woo! Yeah, woo! Yeah. Oh yeah, this is good. This is good. This is good. Good. Yeah. Woo! All right. This. You guys are like dead over there. You guys rocked it out over here. Okay. So can you read this? All right. Is this dark enough ink? A traveling wave. Nope. A traveling disturbance. Traveling disturbance through a medium that carries energy. A traveling disturbance through a medium that carries energy. It's really helpful to understand what all the words in a definition are. Help it, be able to understand what the definition means. So, medium, that's like not big, it's not small, it's just kind of medium, right? No. What does medium mean? Through a medium. Nothing. Anybody? Either. This is material through which a wave travels. This is the material through which a wave travels. Material through which a wave travels. Okay, so in the case that demonstration we just did, what was the medium through which the wave traveled? What was the medium? People, you guys. Okay. So there was the disturbance traveled. You're sitting here, and all of a sudden you're like, whoa! Okay, disturbed. Okay. We didn't really carry energy, but get the idea. Hmm. Yep. It absolutely could. All right, so this is kind of the anatomy of waves. So the amplitude is the distance away from undisturbed medium. The distance away from an undisturbed medium. Um, it's a distance, so it's measured in meters. So this would be the amplitude. Think of like a still pond. You threw a rock in it. The amplitude would be the height of the wave from the still pond, or the depth of the wave from the still pond, from the undisturbed medium, is the amplitude. Okay. Wavelength. This is the length or distance of one complete cycle. The length or distance of one complete cycle. The variable for this is lowercase lambda. You saw this last year in chemistry. It's upside down inverted y, lowercase y. And the unit, it's a length, it's also in meters. So on here, that would be an example of a wavelength. Okay, the length of one complete cycle. And this would also be a wavelength. You go until the pattern starts to repeat. That would be one cycle. Good with that? Questions there? Give that one a shot. Tell your neighbor. Correct answer is? Correct answer is E. Okay. Tell your neighbor what would be a correct dimension for wavelength. Okay. For wavelength, it could be A to E, B to F, or C to G. Okay. Tell your neighbor what would be a good amplitude. You could either do high or IC. Okay. All right. Pretty sure we covered this when we were doing circular motion, but period. This is the time it takes to complete one cycle. The time it takes to complete one cycle. The variable for that is a capital T. The unit for that is seconds. Again, we looked at that with circular motion. Okay. New measurement is frequency. This is how many cycles are completed in 1 second. How many cycles are completed in 1 second? The variable for frequency is a lowercase f. The unit for frequency is cycles per second, which that is equal to a hertz, which is abbreviated with a capital H, lowercase z. The equation that relates these two, frequency and period, is this. Frequency is equal to the inverse of the period. So 1 over the period is equal to the frequency. Okay. So one way to look at this is cycles per second. How many cycles are completed in 1 second for every 1 second? Period can be looked at as how many seconds it takes for every 1 cycle. is a way to look at that. Where cycles isn't really a unit, it's just a counter. Okay. Tell your neighbor. Correct answer is correct answer is A, apple. Okay. You want period, so you want seconds per cycle. How many seconds it takes to do one cycle? So 2 divided by 8. Okay. Conceptual. Sorry. Most definitive way, in my opinion, is to look at the units. So period is seconds over cycles, so 2 over 8. You could also look at it conceptually, like if it did 8 cycles in 2 seconds, the time that it took to do one cycle, is that going to be more or less than 1? Did 8 cycles in 2 seconds. It'd take less than 1 second to do one cycle. Okay. So what would be the frequency? JP. You got the right idea, wrong answer. Correct answer would be 4. Okay. Good with that. It would be cycles per second. Good there? The inverse of the period. All right. There will be a question like this on the test. Not complicated. However, history says popularly missed. So let's try it again. Tell your neighbor. Correct answer is? Correct answer is A. Cycles per second. Cycles, 4 cycles for every 12 seconds. So, what is the period? Correct answer is B. 3 seconds, not 3 hertz, but 3 seconds. How long does it take to do 1 cycle? Okay. Look at the units, my best scenario or best suggestion. Okay. Okay. So, before you took physics class, what was the equation you learned in math class that speed is equal to? Speed is equal to, there it is. Speed is equal to distance over time. Okay. So, if we try to modify this, apply this equation just for waves, what distance do we have that's special to waves? Wavelength. And what time do we have that's special to waves? It's measured in seconds, period. This is the length of one complete cycle. This is the time for one complete cycle. Now, this is the distance for one complete cycle. This is the time for one complete cycle. Okay, so you have wavelength over the period is equal to the speed of the wave. Now, we know also that frequency is equal to the inverse of the period. And right here, we have 1 over t. So we can write this as frequency times wavelength is also a correct expression to calculate how fast a wave is traveling. So all 3 of those are valid expressions for finding the speed of a wave. This last one you actually already used in chemistry. When you're doing spectral lines like colors, you use this equation, which was the speed of light, which is a wave, times frequency, or frequency is equal to frequency times wavelength. So this is a special case for this equation. Good with that? Tell your neighbor. And tell them how you got there. Correct answer is B. Buster Brown. Brown buffaloes. Okay. So you're going to take the wavelength divided by the period. The amplitude is a distractor. Good with that? Okay, try that one. Have a conversation. Hmm? Because it's not light, it's sound. Okay. What do you say? Correct answer is E. Tell your neighbor what the correct answer should be. Okay. You could have done this several different ways. Wavelength divided by the period. Wavelength times the frequency. Or distance converted to meters divided by the time. Good with that? Mm-hmm. Yeah, it just doesn't equal C, it equals speed. Okay. All right. There are two types of ways. Tornadoes, though, don't. You're fine. It goes around the frame. Southern Indiana. I could probably ask for a picture of it. All right.